So today we're going to talk about a different way to solve quadratic equations. So far we have 4 different strategies in our toolbox. The first being solving by factoring and using the zero product property. From there we moved on to solving by graphing, either by hand or on a calculator, finding the x-intercepts. We've also solved by taking the square root of both sides, but remember that only works when I'm missing that middle term, the one just with an x. The b, if you will, has to be 0. And then the fourth that we learned the past few days was completing the square. Today we're going to take it up a notch and learn the last method of this unit. So what I want to think about first, take an equation like this, pretend you don't have a calculator in front of you, and we just have to figure out, can we solve this by factoring? So what I'm looking for are two numbers that multiply together to give me -7 and add to give me a +4. Now pretty quickly I can figure out there are no two numbers that are going to do that. 7 is prime, so it's either going to be 7 and 1. One of them is going to have to be negative. When I add or subtract, I'm definitely not going to get 4. So right now what we have, the only backup we have, we can solve using completing the square, which we know can get a little tedious and lengthy. We could also solve by using the graphing calculator to find those x-intercepts. Now because I can't factor, I can make a prediction that these solutions or x-intercepts are going to be irrational. But we're moving on today to one other way to do that when I do have irrational solutions. The good news is what we're learning today works every single time without fail. Here's the big thing though. Here's my quadratic formula, and I have to memorize that. So what it looks like, the opposite of b plus or minus the square root of b squared minus 4ac, and that whole thing is over 2a. So this is just another method to find the solutions of a quadratic that is in standard form, which is of course in the form 0 equals ax squared plus bx plus c. So a is the leading coefficient, the term in front of x squared, b is in front of just that single x, the middle term, and c is the constant. So you guys are all looking at the formula, probably freaking out because you're going to have to memorize it. Good news is there are plenty of other students that have felt the same way, and they've come up with a fun few tools that can help you remember them. So one of them is this song that's going to be stuck in your head all day. Get ready for it. Because you liked that so much, I'll let you listen to it again. It's a good one. So if you were enjoying the music, you can see on the side here, just by Googling quadratic formula song, there's clearly a ton of students that have done the same kind of thing. I see Taylor Swift, One Direction, all that good stuff. So you guys can enjoy that in your spare time. But for right now, you definitely need to have that memorized. So now the next step is, whoop, we still have stuff going. Close that guy. So the next step is, how is this going to help me? How would the quadratic formula help me solve? So let's go to that same exact quadratic that we were dealing with in the warm-up. All right, so what I'm doing, I have x squared plus 4x minus 7. First step, anytime you're using completing the square, factoring, and using ZPP or the quadratic formula, you want to get everything to the same side of the equal sign. Good news is, in this one, I already have it there. So right off the bat, I can figure out my a, my leading coefficient, my b, the number in front of that x, and c, my constant. So now all you're doing is you're just plugging in that a, b, and c in for the quadratic formula. So x equals the opposite of b. Well, if b is +4, the opposite of that is -4, plus or minus the square root of b squared minus 4ac all over 2a. So notice how anytime I plugged something in, the a, the b, or the c, I put it inside parentheses. Always a good idea so that you're keeping track of the negatives But what I can do now is you can simplify. So let's start with inside that square root, inside the radical. So 4 squared is 16. Then I have minus 4 times 1 is 4, times negative 7 is negative 28. So a double negative gives me that positive 28. That whole thing is being divided by 2 times 1, which is just 2. I can keep going. Negative 4 plus or minus the square root. I'm going to have a 44 on top and a square root of 2 on bottom. Now here you want to take your calculators out. The reason is I know 44 is not a nice, clean, pretty square. So I want to type this into my calculator. Let me try to get this in a good viewing window for you guys. All right. So what you can do, the whole numerator wants to be in parentheses. So right off the bat, throw in a parenthesis, negative 4. Let's just do the plus first, the square root of 44. Move that cursor outside that square root bar. So you'll see it's flashing, but it's not underneath the radical anymore. Close off the parenthesis. Now the entire numerator is enclosed, and now you can divide that by 2. I get one solution. So I know x is going to equal 1.32, approximately. So there's one x-intercept. It's not going to be rational, but it still exists. The nice thing is to enter this into your calculator again, there's a trick, so I don't have to type it in all over. If you hit second, enter, it takes that entry row from what you just typed in the row before and allows you to edit it. So now I can move over, and rather than adding negative 4 plus the square root of 44, I want to subtract. Make sure you're using the subtraction button and not the negative. You can hit enter, and you get that negative 5.32. So I use these little squiggles. All it means is that I rounded. It's not an exact answer. It's an approximation. But you just solved it. Now, could I have done it the same way by completing the square or by using my graphing calculator and finding the x-intercepts? Definitely. Could I have factored this? No, not easily because I don't have nice, pretty rational solutions. So let's try a few more together. If I'm looking at number 1, I have a 0 on one side of the equal sign, so I don't have to move anything over. My a is 1, b is 5, and c is negative 5. So I can plug that right into the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it looks really ugly. Start with the inside here, the stuff underneath that square root bar. So I have x equals negative 5 plus or minus. 5 squared is 25. I get 4 times 1, which is 4, times negative 5 is negative 20. Negative plus another negative turns into a positive. So I get that plus 20 on the inside. I'm dividing the whole thing by 2. Still need to combine those two like terms inside that radical, the square root bar. So now I get negative 5 plus or minus the square root of 45 all over 2. Now I'm not going to have rational solutions because I know 45 isn't a perfect square. So type it in your calculator again. Put parentheses around the whole numerator, the top half of the fraction, negative 5 plus the square root of 45. Again, move your cursor so it's on the outside of that square root bar. Close off the parenthesis and divide by 2. So that's one solution. X is going to equal approximately 0.85. So there's one x-intercept or one solution. You can hit second, enter, and again it pops up that row from directly above and lets you edit it. So I'll just move my cursor over, change the addition sign to a subtraction sign, hit enter, and you get negative 5.85. All right. The last one we'll do together, and then you guys will be off on your own. So clearly everything's not on one side. So before you can use the quadratic formula, you have to get all of the terms on one side with the 0 on the other. So negative 3x squared plus 5x, add that 2 to the other side, and now I have the equals 0. So a equals negative 3, b equals 5, c equals 2. So here we go. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So when I simplify, I'm going to start with the inside of the radical. So I have negative 5 plus or minus 5 squared is 25. I get 4 times negative 3, negative 12. Negative 12 times 2, negative 24. When I subtract a negative, I get a positive. Divide that by 2 times negative 3, which is negative 6. So the last step to simplifying that radical, 25 plus 24 gives me 49. Divide that by negative 6. Now here, I'm going to get nice rational solutions because 49 is a perfect square. So I don't even need my calculator here. I have negative 5 plus the square root of 49, which is 7. Divide that by negative 6. So here on top, negative 5 plus 7 is 2. Divided by negative 6, that reduces to negative 1/3. So there's one of my solutions. The next, negative 5 minus 7 divided by negative 6. You'd get negative 12 divided by negative 6, which gives you a positive 2. So here again, two solutions. Now they're exact because they're rational, meaning nice and pretty. Now because I have nice and pretty solutions, was the quadratic formula the most efficient? Probably not. Factoring would have been faster. But again, as I said at the start, this is the always, this method always works. So as long as you're plugging things into your calculator correctly and simplifying the inside of the radical, and big thing, you get the formula correct, this is a surefire way to get solutions to quadratic equations. So what we want you to do before you come to class tomorrow, do 3 and 4 on your own, use your calculator if you need to, round to 2 decimal points the same way we did. Bye guys.